Welcome back to our Six Sigma series. Today, we dive into the measure phase, where data becomes your best friend. Understanding how to accurately measure processes is crucial in Six Sigma. Let's explore how to master this step and set the stage for impactful analysis. The measure phase is a cornerstone of the Six Sigma methodology. This step is about defining what needs to be measured, collecting accurate data, and establishing reliable baselines. Key elements include understanding measurement systems, defining key performance indicators, and assessing the quality of your data. The measure phase involves critical tools like FMEA, which helps you identify potential failure points and assess their impact. Understanding data types, whether continuous like temperature or discrete like defect counts, ensures you use the right statistical methods. Lastly, measurement system analysis, particularly Gage R&R studies, validates that your measurement tools are reliable. These concepts lay the foundation for meaningful data analysis. FMEA, or Failure Modes and Effects Analysis, is a powerful tool used in the measure phase of Six Sigma to proactively identify potential failure points within a process. By evaluating each failure mode based on its severity, frequency, and ease of detection, FMEA helps teams prioritize issues that pose the most significant risks. This method allows you to implement corrective actions before problems impact your customers. Understanding data types is critical for selecting the right measurement tools and analysis methods. Continuous data can take any value within a range, while discrete data consists of countable and distinct values. In the measure phase, understanding the type of data you're working with is crucial. Continuous data, like temperature readings or cycle time, offers precise measurements and is ideal for statistical analysis. Discrete data, such as the number of defective items or customer complaints, is countable and often used in quality control charts. Knowing the difference helps ensure you apply the correct analysis techniques for accurate results. Measurement system analysis, particularly Gage R&R, ensures that your data is reliable by evaluating your measurement tools and processes. Gage R&R studies assess both repeatability, defined as how consistent your measurements are when taken by the same person, and reproducibility, defined as how consistent they are across different operators. This validation is essential to prevent errors that could mislead your analysis and decisions. For example, a manufacturing plant evaluates their torque wrenches used in assembly to ensure consistent tension across all bolts, reducing the risk of faulty assembly. Data collection is a cornerstone of the measure phase, providing the essential information needed to understand and improve processes. Let's explore three key data collection techniques: simple random sampling, stratified sampling, and run charts. Simple random sampling is a method where each data point has an equal chance of being selected, ensuring a fair representation of the entire dataset. This technique helps reduce bias and provides an unbiased snapshot of the population. For example, a retail chain might randomly select 50 receipts from different locations to analyze sales patterns. This approach ensures that the data reflects the overall sales performance without skewing results toward any particular store or product. Stratified sampling involves dividing data into meaningful subgroups, or strata, before sampling. This method allows for targeted analysis of specific groups within the overall population, improving the accuracy and relevance of findings. For instance, a hospital might use stratified sampling to divide patient wait times by age groups, enabling them to study differences in service efficiency across demographics. This approach helps the hospital identify if certain age groups are experiencing longer wait times, allowing for tailored improvements. Run charts are time-based visual tools that plot data points over a specific period, revealing trends, shifts, or cycles within a process. They are especially useful for tracking performance and identifying patterns that may indicate areas for improvement. For example, a manufacturing plant uses a run chart to monitor daily production output, allowing them to quickly spot deviations from the norm, such as a drop in productivity or recurring peaks that might suggest inefficiencies or equipment issues. Together, these data collection techniques help Six Sigma teams gather the right information, enabling accurate analysis and informed decision-making that drives process improvements. Establishing a baseline performance provides a snapshot of your current process, showing where it stands before any improvements are made. This baseline acts as your starting point for measuring future progress. Process capability analysis then evaluates how well your process meets performance standards, using key metrics like Cp and Cpk to determine consistency and ability to meet specifications. Think of the walls of your garage where you have to fit your car. Imagine your garage walls as customer specification limits. If your car goes beyond these limits, you'll crash, just like a process exceeding customer standards. When your process has high variation, it's like parking all over the place, risky and inconsistent. To park successfully, you need to reduce variation and center the process. If your car is too wide, centering won't help. You need to reduce the car's size, similar to reducing process dispersion. But if your car is smaller than the garage, it easily fits, even if it's not perfectly centered. This illustrates why Six Sigma focuses on minimizing variation. A controlled process with little variation consistently meets customer requirements, just like easily parking a well-sized car in the garage. CPK measures how well your car, the process, fits within the garage, the spec limits, and how centered it is. If you are interested to know more about the calculation and analysis behind, contact us via our website, www.avaconsult.com. Let us talk about the practical tips and common pitfalls in the measure phase. Even small measurement errors can lead to big problems. Avoid common pitfalls like using outdated or uncalibrated tools. Regularly calibrate your equipment, validate your data collection process, and ensure environmental factors don't skew your results. These best practices help you maintain data integrity, setting the stage for successful analysis and improvement. Before transitioning to the analyze phase, make sure your measurement systems are validated, data is collected accurately, and capability assessments are done. This checklist ensures you've covered all bases for a smooth and effective analysis. Accurate measurement is the foundation of Six Sigma success. By mastering the measure phase, you set up your team for insightful analysis and impactful improvements. In our next video, we'll explore the analyze phase, where we'll dig deeper into the data to uncover the root causes of process inefficiencies. To know more about Lean Six Sigma, don't forget to subscribe and like this video.